Okay, so we have understood what an inverse function is. We also learned how to check if the given functions are inverses of each other. The next question to ask is, when does an inverse function exist? Now, note that a function, this is going back to week one, requires that each input has exactly one output. Now, inverse functions, we're using the word function, so they are functions too. So it must be true for them as well. Now, for an inverse function, what's the relation between the input and output? Is that whatever the input is for the normal function is the output for the inverse function, right? So if this is a, that's a here. And whatever is the output for the function is the input for the inverse function. So for inverse to be a function, each output must correspond to exactly one input. This property is called being 1, 1. Here's two examples how you can check. Let's say this is a function. Now you can check. If I draw this horizontal line, that's an output. And this output corresponds to exactly one input. Now if I move this horizontal line, I still have one input for every output. So this is good. This is said to be 1, 1. But if I take a function like this, right here, that's my output, but I have two possible inputs. Yeah, so this is not 1, 1. So the horizontal line test basically is similar to your vertical line test for functions. Remember, if the vertical line intersects at more than one point, it's not a function. Similarly, if a horizontal line intersects at more than one point, it is not 1, 1. That implies that inverse does not exist. Right? So if a function is 1, 1, the inverse exists. Otherwise, it does not. So now we know how to check for existence. Let's see how to find the inverse. Now, finding the inverse is essentially, you have to remember, inputs and outputs are getting swapped, right? So I write this function. Remember, that's the output and x is the input. So we swap x and y. So this becomes x equals 4y cubed minus 1. And now we solve for y. Solving for y makes this x plus 1 equals 4y cubed. Y cubed equals x plus 1 over 4. So y is cube root of x plus 1 over 4. And the notation for this is f inverse of x. This means f inverse of x. And you can verify how. If I take 4x cubed minus 1 and I take the cube root of this plus 1 over 4, it gives me cube root of x cubed, which is x. And if I take 4 cube root of x plus 1 over 4 cubed minus 1, that's 4 times x plus 1 over 4 minus 1, which is x. So it adds up, and in fact it is the inverse. Here's the flowchart. Given y equals f of x, you interchange x and y, then you solve for y, and then you report the expression for y as f inverse of x. Graphs of inverse function. Inverse function, again, they're obtained by interchanging x and y, that is the input and output. We can obtain the graph by taking a reflection along the y equals x line. Because essentially what you're saying is you're changing the input, which is x, becomes the output, which is y, and the output becomes the input, and that corresponds to moving to the y equals x line and then coming back down. So it's a reflection. Verify with this particular graph. Okay, let's say this is my function y equals x plus 3. When x is 0, y is 3. So that's right here. When x is negative 3, y is 0. That's my line. y is x plus 3. This is my line y equals x. This is y equals x plus 3. And then this is 1, 2, 3, 1, 2, 3. This line is y equals x minus 3. And these are reflections of each other if you look at y equals x as a mirror. Ending this video here, and we're going to combine the two topics of exponential functions with inverse functions to end this week's video.